Hello and welcome to this video lecture for Chapter 2. So Chapter 2 is about design objectives. The topics that we'll be talking about and you should be thinking about is why should we be concerned with database design? What are the advantages of learning a good design methodology? The objectives to good design and database design methods. And so as we look at why you should be concerned with database design is because if you have a poorly designed database that's holding the information, it's going to make it difficult to get the information back out. And you may get inaccurate information. And because you've got inaccurate information, you're going to make bad decisions. So keep in mind, again, we've got this data that we've collected. Now we've got to aggregate it, put some context with it, turn it into information, and then when we make decisions with it, it becomes knowledge. So if we look at this definition of design, design is arranging the building blocks so that you can achieve your desired results. Designing and building are not the same thing. So I like to think of design, when you're thinking about database, you have a logical design. And then when you start to build it, it becomes physical. Some people refer to that as the physical design. One reason why we're talking about design and you're in this class, you're not going to be database administrators. But what you may be called upon to do is be a database architect. That is, somebody's going to say, okay, you need reports, you need to get information. How are those reports going to be arranged? What data do you need for those reports? How should this be designed so you can easily get to that information? And so if you're using a relational database management system, those tools are only effective after you created that database structure. So you have to think about what you're doing and why you're doing it. I always like to say that the output, in this case the reports, determine what your inputs are going to be, and the inputs is the type of data you need to collect. So that design of your database is critical for at least 3 of these items listed here. One is to make sure you have consistent data, so you can make sure that that data is spelled the exact same way as it goes into the database. I mentioned this in the last chapter in terms of think about how you might spell a state and all the different abbreviations that might go with that. You've got to make sure the data is consistent as it goes in. Otherwise, you've got to do a query that takes into account every possible way that data may be represented. So if you only can make sure it's represented one way, then you only have to query it one way. Then we talk about data integrity. You don't want to let values in to a field that don't make any sense. An example might be age. Well, you don't want to let somebody type in 999 for age, even though you might allow for 3 characters. And so you might specify that the data falls in a certain range, maybe 15 to 99, even if you're not even collect all the way up to 99 or 100. But you don't want to take data that's outside of that range. So putting in bad data like that, not only if you generate a report, you're going to get data that doesn't make any sense, especially if they got the 999 value. But then if you take an average, you want to know the average age of your clients or whatever you're looking at, having those invalid numbers in there is going to throw your calculations off. And so again, you look at your accurate data here. And so your database, when you design it, is going to make sure that it's going to make the data as you can enforce certain rules where it's consistent, it has integrity, and it's accurate. So again, I would stress, the logical design of the database is like the architectural blueprint. That's why you're in this class, so you understand that and think about how you can build things better. And then the physical database is the implementation of that logical design. So the logical design actually describes the size, shape, and necessary system for your database. So if we put in how many tables we need, what the tables contain, what size the fields should be, what the data type of the field should be, and so on, that could all be part of that logical database design. And so you do that again by looking what is it that you need this database to produce. So the reports, that is. So that's where it addresses the informational and operational needs of the business. So those reports, the reason why we're collecting this data in the first place. Now, what I want you to get out of this class is that you have some understanding of what it is to have a good design. And so when we think about a good database design, it's going to be one that gives you accurate information. It allows you to store the data more efficiently and effectively, and it's easier to manage and maintain. And so when we say maintain, it's usually when you have to do updates to the data, that is, you make changes. Well, if you've got your data repeated in numerous tables, which would be poor design, then in order to maintain that, you have to be able to make sure you've updated all that data that needs to be changed in all those different tables. Miss one or two, and now your reports are inaccurate, and you're making bad decisions again. The next thing I'm going to discuss is the advantages of learning a good design methodology. The first advantage is it gives you the skills you need to design a sound database structure. That structure allows you to avoid data processing problems related to redundant data, duplicate data, invalid data, and missing data. So when we talk about missing data, an example might be entering information for a record and leaving a lot of the fields blank. Well, with the database management system, you can force the user to enter values before they enter the record, or they weren't allowed to enter the record or save it. The second advantage to good design methodology is that it gives you a set of techniques that will help guide you step by step through that design process, which means this will allow you to make informed decisions about the design. The third advantage is it helps you keep your missteps and design reiterations to a minimum. What we mean by reiterations is that once you develop a portion of that database, you need to go back and make sure it still satisfies other requirements, and so that's the reiteration. So you don't want to have to keep doing that over and over again. You want to minimize the number of times that you do that. And as you're learning this methodology, that's going to help you recognize your design errors and then correct them before you actually do the physical design. Because once you do the physical design and think, oh, I didn't logically design this here, you may have to go back and change a lot of different tables. And once the data is sitting in a table and you've got it related to other tables, it's not going to let you make those design changes easily. You're going to have to undo the relationships, make your changes, hook up the relationships again, and make sure that the data is still the correct data that's making the link. So related to that is the advantage here. 4, it makes that design process easier and reduces the amount of time you spend designing your database. So to me, the key thing there is you want to put in a lot of time initially in your requirements analysis before you actually start doing any physical design. So work it all out on paper, what you're going to produce, what kind of data and what kind of tables that data needs to be stored in and how they're related before you ever start physically designing something. and that will save you a lot of time. The fifth advantage here is because you've gone through that process, it's going to help you understand and use your database management system application program better and more fully because you're aware of how everything is related. And there may be reports that you want to run that weren't automatically built. So a lot of times when you build a system or have a system, you have default reports. Well, maybe a manager wants reports that includes different types of information, and now because you're aware of how everything was designed, you'll be able to grab those tables and use that to retrieve the information for an ad hoc type of report. So that leads us into the objectives of a good design. So it should support both required and ad hoc information retrieval. Those are those reports I keep talking about. So you've got to learn to think about what your users are going to need. So you want to anticipate their needs. And so the second objective is that your tables are constructed properly and efficiently. You don't want to collect data or calculate data in your tables that can be calculated on the fly. An example might be, let's say you wanted to know what the cost of an inventory of an item is. Well, if you've got the price collected of an item and the quantity that you have on hand, then price times quantity tells you how much cost or inventory you have of all those items. But you don't want to store that information because you've already got price and quantity. And so that's what we mean by efficiently. So as you look at that efficiency and construct it properly, each table should only collect data about a person, place, or thing. One person, place, or thing. Or in this, what it says here represents a single subject. You don't want to have students and courses collected in the same table. You'd want to split those up into two different tables and then link them. That's what we're talking about. You're going to have distinct fields. That is, you're going to collect only one type of data in each field. You're not going to collect first name and last name in one field. You're not going to collect their street, city, and zip code all in one field. You're going to break that out into different fields. So that's what we mean by distinct fields. So we're going to try and keep that information or data to a minimum. So that's how we would link the data. A third objective is the data integrity is imposed at the field table and relationship levels. You'll see this in action when we create our access tables and work with our access database. But when we look at that and do that, it guarantees validity of your data structures and values. So if they're not valid, then the decisions you're making with it are invalid as well. And I've talked about how we do the integrity of the field, the table, and I'll show you here in a little bit how we make sure that integrity, at least at the logical level, for the relationships should be implemented. The fourth objective of good design is that the database supports the business rules that are relevant to the organization. That is, we need to provide valid, accurate, and meaningful information. And this is the context in which we spoke about that. So a business rule that you would understand is that students aren't allowed to take more than 18 hours in a semester. So you could actually do that total when somebody's registering for classes, and then if they try to register for more than 18 hours, it throws up a nag screen, if you will. Now that can be overridden, but it's following the business rules. Or, you can't take more than 12 hours above a division College of Business classes would be another business rule, and we can use the database to implement that and help us follow those business rules. The last objective is the database lends itself to future growth. That is, we need to design it in such a way that it'll be easy to modify or expand. We don't want to have to redo the entire physical structure because we added another field in a table somewhere. Okay, I'm going to stop here, and when we come back, we will talk about the benefits of good design.